So 2-point perspective is when you have an object that like a two sides, they're important two sides, like in this building, both in this direction and that direction has some interesting features. You want to show equally on the left and right sides. Okay, it's like in buildings. So that's why you want to use a 2-point perspective. So we can construct an x and y and z coordinate system like so. Then there's a right x direction and there's a y direction, and z is the vertical direction. So in this case, the object that is a vertical direction, like these lines here, all these lines, if you project it in 2-point perspection, they're going to stay as vertical lines. But any lines, horizontal lines in either x direction or y direction, they're no longer be a horizontal line. They're going to be all pointing to either vanishing points. So any lines that are parallel to x directions will converge to the right vanishing point. Any lines that are parallel to y direction, they're going to be converged to the left vanishing point. So this is a left vanishing point, and this is right vanishing point. Again, any lines that are parallel to x direction. So here, the red lines. So this the roof line and this windows lines, all those lines, they are actually in the building. They're going to be all parallel to x direction, right? So those lines that are parallel to each other and also along the x direction, they're going to be all converged to the right vanishing point. Whereas these lines here, okay, all these lines on this building, they are in the same direction as y, and they are all parallel to each other. All those lines will converge to the left vanishing point in this 2D image, okay? All right, so let's use this as an example. This is again orthographic project kind of a house. Like in this case, regardless of where that is located, this length and that length is identical. Okay, so this is orthographic projection, but we want to sketch this in 2-point perspective sketching. So the first thing you want to do is, because this is get more complex, we want to first construct a bounding box. Okay, so bounding box is a box that fits the object snugly. Okay, so you can find the kind of the smallest number of box that fits the object, and then also this box location has to be in the x and y and z aligned. Okay, so box has to be aligned along the x and y and z, and you construct the object that is smallest, snugglest fit. So in this case, so this point is right at these points are right at the top surface of the bounding box, and these lines has to be at the bottom, right? And this line has to be at the frontal surface, and so on. Okay, so it has to be find the snugly fitting box, the smallest box that contains the object. Okay, and there's a bounding box, and we can measure what is the width and depth and height of that box, and we want to focus on sketching the box first. Again, don't look at the details of the complex object. We want to construct a minimum box, and we will sketch the minimum box first. So here is the W width and depth and height. And then we want to first sketch the nearest corner line of the box, AB. Okay, so we label them as AB box, and then they're going to be a vertical line. That's gonna be a vertical line. So as I mentioned in the 2-point perspective, the vertical line of the real object will be projected as a vertical line in 2-point perspective. Okay, so in order to do that, again, the same way, we have to decide where the horizontal line is on the paper. So if you want to see from the top, like bird's eye view, I want to draw the horizontal line at the top. If you want to see worm's eye view, you have to draw your horizontal line at the bottom. But I want to see more like a roof side of the building more. So I want to have like my eye level has to be really high. Okay, so that's why I draw my horizontal line up there. And then we have to decide two vanishing points. So I choose the 2 points right there. There's actually the left right vanishing point doesn't they don't need to be inside the boundary of the paper, so you can consider this horizon line to be like infinite line, and it could be anywhere on the horizon line even if they are not in the boundary of the paper. Okay, so actually the closer the two points, two vanishing points, the your object will be really distorted. So it's not actually good to have those two vanishing points closer to each other. The farther they are away, they look more natural. I mean, they less distorted. But just to show how they work, I just use these 2 points as left and right vanishing point. Now, of course, those two vanishing point has to be on the horizon line. They can't have any other points that are not on the horizon line. Then we sketch the vertical line AB. So depending on, so the like I mentioned, any vertical line in the object will be drawn as vertical line. So we can sketch this line AB, but the question is where we locate them. Okay, you can make it left and right, or even make it small or large, right? So your location, horizontal location, will determine its orientation of the house. So if you draw your AB line on the more left hand side, then you're going to see more of this right side of the building more. And if you put your AB line to the right, and then you'll see more the left hand side of the object on your sketch. So you have to decide where AB line should be. Okay. And then the size of the line AB will scale the object sketch. So if you draw AB line large, then you're going to draw a big sketch, big house. If you draw AB line small, then you're going to have like small house. You are sketching. So you want to draw like appropriate number, appropriate size of the line AB and appropriate location. Maybe you have to do like a trial and error again to find the correct location and size. Anyway, you once you determine A and B line and draw your vertical line on there, then also you have to draw this lateral lines, right? Lateral line of the box. Okay, so remember that we are just sketching the box. Okay, so we are sketching the box. So what we need to do is these two lines, and again, they are parallel to each other, and that's gonna be parallel to the y direction. Okay, so this and that are parallel to the y direction. So that means those two, from this 2 points, the lines will be like that, and they'll be pointing to the left vanishing point. All right, so same thing happens here. These two lines are parallel to each other, and they are parallel to the x direction. So they're going to be all pointing to the right vanishing point. Okay, so that's how it's sketched like this. All right, then we do the same here because we know the width of that. Again, there's a way of you can estimate more accurately, but we're just gonna eyeball it. We just draw this line CE, which is this, right? So any lines in the object, the vertical line in the object, will stay vertical. So we will just draw line CE and FG, all right? And just cut them vertical direct lines. Okay, so that's going to be W and D with them depth. And as you can see here, the line AB, the height, these three lines should be the same height, H, but they will look different in the perspective sketch. Okay, line AB will be tallest, FG is the second, and C is the smallest line. Although in real object they are all same heights, but in perspective sketches they look all different sizes. Then we do the same thing. We just draw from the line all the points to the left and right vanishing point. So any lines, like these lines, are all parallel to X direction, right? So that those lines are all uh, converge to the right vanishing point. And any lines that are parallel to Y direction, they're going to be all converge to the left vanishing point. So that's why you draw that. And that actually, that is the box. Okay, so this represents the box. Okay, so can draw like hidden lines there, hidden lines there, hidden line. So that's gonna be the box. So as you can see, it kind of like a bit distorted. Okay, so this looks like a more regular shape. This is an orthographic projection, and in perspective sketch, your rectangular box is kind of look distorted. And actually, that's how you see things through your eyes. So you have a large, long building. If you look at it, the back side of the building will smaller and the frontal side will look large. So you can, after sketching the box, then you can complete the house using the same principle. Okay, so any lines that are parallel to X direction of your building, you just draw a line, but that has to pointing to the right vanishing point, and any lines in the X direction, Y direction, has to point to the left vanishing point. Okay, so if you have any random line on your object, then maybe you have to pick up 2 points and where they're located, and you have to like interpolate them. But that's how I can sketch. Okay. Again, this you may not completely understand how this works. I didn't really go into detail how this actually the mechanism works, but that's okay. We're gonna just do this today only, and we'll never use this perspective sketch in this course. What you're gonna talk about more in detail is gonna be the orthographic projection, starting next lecture. Okay. So you just understand the difference between the perspective sketches and the orthographic sketches, and just understand why we don't use perspective sketching in manufacturing or mechanical engineering drawings, because we have to measure the size of the, let's say, the house, right? But that depends on where that location of that line is from your eye. Okay, so you have to know all kinds of other information to actually measure the height of this house. Uh, so you have to measure the object length directly from the drawing, but if that involves a lot of calculations, which is very difficult to do, that's not good way of communicating for manufacturing, right? So that's why we use orthographic projection, not perspective projection. Although the perspective projection drawing will look more natural and to your eyes, because that's how we actually see. Uh, all right, so that's that. So if you see that a lot of sketches, conceptual sketches that follow this rule, I can find some 1 point and 2 point perspective vanishing points in your drawing, and even the paintings. Uh, if you want to show like a depth information in your painting, they follow the same rules, and and vanishing point and all on the same rules.